Hey everybody, we are live and in stereo. So today we'll be solving the latest paper that has been tested by Cambridge International Examination when it comes to MCQs, obviously, in its February-March 2024 examination series, for which the code is 0620 and the variant is 22. And obviously I had to make a video because all of you were pestering me so much, sir, to make an explanation to this paper. So here we are. Now it is very important to do this paper before attempting your May-June 24 examinations because this will give you an idea of how Cambridge is going to test you this year, and it's also going to boost your confidence and put you at an advantage if and only if you understand this paper thoroughly and conceptually, right? So I'm going to dissect each and every MCQ for you. I'm going to go into the in-depth explanation to why each and every MCQ is wrong. That might be the reason why it may take me more than 45 minutes to solve this paper, but I'm going to make sure that none of your concepts remain ambiguous, right? So without further ado, let me write my name. It's obviously Suleiman Khan, like the Britishers say Khan. Yeah. And let's dive into the MCQ. So solid X, MCQ1 says solid X is heated for 600 seconds, and he's shown you this beautiful heating curve. A heating curve shows you how the temperature of a substance changes as it is heated, right? So initially you had a solid, you heated it up. Obviously when you heat the solid up, it's going to take in that heat energy and the temperature is going to increase, and then it becomes constant. Remember, when the temperature is constant, there is a change of state. So this solid is going to convert into a liquid, right, at this particular temperature, which is the melting point. And after all the solid has been converted into a liquid, only then will the temperature start to rise, and again it becomes constant at time equals to 400 seconds. Why does it become constant? Because now this liquid is going to change its state into a gas, and after all the liquid has changed its state into a gas, only then, or have converted into a gas, only then will the temperature of the gas rise. Now the question is, why is the temperature constant? Well, you've obviously studied it, and that's not the requirement of the question, but you've already studied it, that the heat energy is no longer used to raise the temperature of the solid, rather it is used to overcome the intermolecular forces of attraction or to break the bonds that hold the solid in place. And that is why we also call it the latent heat, right? So when it comes to melting point or boiling point, the temperatures are constant, and that's the definition of a melting point. Melting point is the constant temperature at which a solid changes its state into a liquid. So what is that temperature? Well, you just coincide this. Obviously, we draw construction lines, coincide it right here, and that is 170 degrees Celsius. How do I know? Well, between 200 and 100, that's 150, this is 160, 170. So B is the correct option. And even if he had said, what is the freezing point, it would still be 170, because effectively you realize that melting point and freezing point are the same thing. Same thing, not ting, yeah? Melting point and freezing point are the same things. Boiling point and condensation point are the same things. The only difference is whether you're heating it up or cooling it down. When you're heating it up, you call it the melting point and the boiling point, and when you're cooling it down, you call it the freezing point or the condensation point. And if he had asked you what was the boiling point of this particular, in this particular question, then the boiling point is the constant temperature at which a liquid changes its state into a gas. So you're gonna draw construction lines and read the recording right here on the y-axis, right? MCQ2 says which statement about diffusion is correct. Now it says aqueous ions cannot diffuse in water. Oh, you dumbo, aqueous ions can diffuse in water. If this was the case, then all the transition metal ions which gave you colored solutions would only give you a color in one part of the solution, and the rest of the solution would remain colorless, right? Is that the case? No. If you talk about the copper 2+ ion, it gives you like the blue color. If you talk about the chromium ions, it gives you a green solution, right? And this green color is spread throughout the liquid, right? So the ions are diffused throughout the liquid. If that was the case, then ions you would only have a green color in one part when it came to the chromium ions, or a blue color in one part when it came to the copper ions, and the rest of the solution would be colorless, which is absurd, right? So no, aqueous ions can diffuse in water. That's wrong. Diffusion is caused by the movement of the random movement of particles. Absolutely, because diffusion is the random movement of gas particles or liquid particles from a region of high concentration to a region of low concentration down the concentration gradient. So yes, that's true. Particles spread out in all directions in diffusion. Absolutely. And you could think about it. I'll give you a very disgusting example. Like if somebody farts, the people sitting in front of him, at the back of him, towards his left and right hand side, all of them can smell that nasty fumes, right? So yes, the particles do spread out in all directions, because that's a practical example. That's the fart source, and all the fumes can go out in every direction. Done. So particles do spread out in every direction. Diffusion can only take place in solids. No sir, diffusion does not take place in solids because solid particles cannot move. They vibrate about a fixed position. And even if you did not know this, you could have easily eliminated MCQ 4 because you would have understood that diffusion also takes place in gases. So 2 and 3 are correct, therefore C is the correct option. Which statements about an atom of fluorine is correct? So it has 9 protons, it has 19 minus 9, it has 10 neutrons, and it has 9 electrons as well because it's a neutral atom, right? So for a neutral atom, the number of protons and electrons is same. It contains a total number of 28 protons, neutrons, and electrons. Absolutely. If you sum all of these up, it's going to sum up to 28. But let's check out why B, C, and D are wrong, because it's a very ambiguous statement. It contains more protons than neutrons. No, sir. Protons are 9, neutrons are 10. Its isotopes contain different number of protons. No, sir. Isotopes are different atoms of the same element having the same number of protons but different number of neutrons or nucleons. Its nucleus contains 9 neutrons. No, sir. It contains 10 neutrons. 2 of the isotopes of calcium, and that's why A is correct, although it's such a stupidly designed MCQ, to be very honest. 2 of the isotopes of calcium are presented as calcium 40 and calcium 44. Which statement explains why these isotopes of calcium have identical chemical properties? Remember, chemical properties depend on the valence electrons, or you could say it depends on the electronic configuration. If they have the same electronic configuration or same number of valence electrons, only then will they have identical chemical properties, right? Both isotopes have the same number of neutrons. Sir, firstly, they don't have the same number of neutrons. This has 20 neutrons and this has 24 neutrons. So that's wrong. But even if the examiner had said they have different number of neutrons, even then I would not check A out because that's not the reason, that's not the explanation to it. So if I were the examiner, I would make this MCQ harder by giving you correct statements. Both isotopes have an electronic configuration of 28A2. Absolutely, because it has 20 electrons. The first shell holds up to a maximum of 2. The second will hold up to a maximum of 8. So will the third. The fourth can hold up to a maximum of 8, but you are only left with 2 because out of 20, 18 are already accommodated. So you only left with 2. Therefore, B is the correct option. They have the same electronic configuration, and that is why they have identical chemical properties. Both isotopes have a mass number of 20. No, sir. One has a mass number of 40 and the other one has a mass number of 44. But even if he had written the correct statement, it would have been wrong because it does not explainary this thing, right? Both isotopes have 4 fully occupied electron shells. No, sir. The last shell is not fully occupied. If it were fully occupied, it would have 8 electrons. It would have a complete octet. Which statement describes a property of potassium iodide? Potassium iodide, Ki, is a solid ionic compound, and ionic compounds are not insoluble in water, they are soluble in water. And even if you did not know whether they were soluble or insoluble, you would have remembered your reaction when chlorine was displacing the iodine in its solution, right? So chlorine was displacing the iodide ion from its salt, and how was it displacing it from its salt solution? Because it was aqueous, right? So that's why I know that Ki is aqueous, it's soluble in water. It is volatile. Are you dumb, man? What's wrong with you? Volatility refers to how easily particles can escape into the air. Potassium iodide is an ionic compound with strong electrostatic forces of attraction which holds the oppositely charged ions in place. So B is wrong. It has a low melting point. It's an ionic compound. Again, they have high melting points because they have strong electrostatic force of attraction. It conducts electricity when molten. Absolutely, because when you melt them, the lattice breaks, you have free moving ions, and free moving ions can carry charge and therefore they can conduct electricity. Methanol has a boiling point of minus 19 degrees Celsius, which means at minus 19 degrees Celsius, boiling point refers to when a liquid changes its state into a gas at a constant temperature. So it's the constant temperature at which a liquid changes its state into a gas. So before minus 19 it must have been a liquid, and after minus 19 it must be a gas. And that's why I saying as at minus 20, so minus 20 is before minus 19, right? That's why saying it's liquid methanol is a non-conductor of electricity. Good. And what is methanol? It's an aldehyde, not in your course. Don't get confused with these jargons. In a sample of methanol, each atom of carbon, hydrogen, and oxygen has a noble gas electronic configuration, and obviously they would have that electronic configuration because that is the reason why atoms react. Atoms undergo chemical bonding to attain stability, to attain a stable electronic configuration. Each atom has achieved its electronic configuration in three ways. In one of the three ways: gaining, losing, or sharing. Sir, no gaining, no losing, only sharing. Why? Because carbon is a non-metal, hydrogen is a non-metal, oxygen is a non-metal, and the type of bonding that takes place between non-metals is covalent bonding. There is a gain or loss of electrons or a transfer of electrons when you have a metal and a non-metal. So this happens in ionic bonding. Sir, please. So it's only sharing of electrons. Which statement describes the bonding between carbon atom and oxygen atom in methanol? So you have carbon and you have two hydrogens and you have an oxygen, and you could use your ideas of chemical bonding that, hey, oxygen can make two bonds, each hydrogen can make a single bond, and carbon needs to make four bonds. Why do we know that? How do we know that? Well, obviously because oxygen is in group 6, it needs two electrons to become stable. That's why it makes two bonds, right? So it make two bonds with carbon will make one bond here and one bond here, and that's the structure of methanol for you, right? So carbon has made all the four bonds, oxygen has made a double bond, hydrogens have also made the single bond. Now it says, which statement describes the bonding between carbon atom and oxygen atom? He's only talking about this carbonyl. It's only talking about carbon and oxygen atom. Well, we know that there is a sharing of two pairs of electrons, essentially, which are 4 electrons. Now, the carbon atom and the oxygen atom share 4 electrons. Absolutely, they do, right? They share 4 electrons, but they are two pair of electrons. The carbon atom and the oxygen atom share 2 electrons. No, sir. They share 2 pairs of electrons, not 2 electrons. Carbon is a negative ion, sir. No negative ion, no positive ion. It's a non-metal. Non-metal don't make non-metal in covalent bonding do not make any ions. The structure of diamond and graphite are shown. Obviously, this is diamond and that's graphite. This is diamond because each carbon atom is covalently bonded to 4 carbon atoms through strong covalent bonds, and that's the structure of a diamond arena. And here, that's the hexagonal sheets. This is a tetrahedral shape. That's the hexagonal sheets, and you have weak forces between them due to which the layers can slip and slide. And because each carbon is covalently bonded to only 3 carbons, 1 electron remains, and that's happy, and that's delocalized. So 1 electron, because of the 3 bonds carbon is making, 1 electron remains delocalized, due to which graphite can conduct electricity. And for diamond, it can't conduct electricity because it has no delocalized electrons to carry the charge, right? All the electrons are involved in bonding. Diamond and graphite contain strong covalent bonds. Absolutely they do. They're giant covalent molecules. No, not molecule. Yes, you can call them molecules. You can't call them compounds, right? So they're giant covalent molecules, or you could call them giant covalent structures, or you could call them macromolecules. Diamond and graphite have delocalized electrons. No, sir. Diamond does not have any delocalized electrons. Only graphite does. Diamond and graphite have layered structure. No, sir. Only graphite has a layered structure. Diamond doesn't have any layered structure. Graphite and diamond have low melting points. They have high melting points. Why? Because it's not a simple covalent molecule, it's a giant covalent molecule or a giant covalent structure. Which row contains a description of metallic bonding and a property that is explained, right? So he wants the description and an explanation to that description, a property that is explained by the reference to that description. Okay, great. A lattice of negative ions, no, it's a lattice of positive ions in a sea of delocalized electrons, so A and B are wrong. A lattice of positive ions, okay, C and D. Now, check the explanation out. It's a lattice of positive ions in a sea of delocalized electrons. Is that the reason why metal can react with an acid? No, sir. Metal can react with an acid not because it's a lattice of positive ions in a sea of delocalized electrons. It can react with an acid because it has 1 electron in its outermost. It is more reactive than the hydrogen in the acid and can displace the hydrogen in the acid, and therefore it can react with it. So that's the chemical properties. Chemical properties depends on its electrons, depends on its chemical behavior, depends on its reactivity. It does not depend on because it's a lattice of positive ions, right? So C is therefore wrong. And to check D out, D says it's a lattice of positive ions in a sea of delocalized electrons, and a piece of metal can be molded into different shapes. Yes, because we're saying it's a lattice. Lattice means it's a regular structure, and that is why the layers can slide over each other, and we say it's malleable and ductile, and therefore you can mold them into different shapes. So D is absolutely right. What is the MR of sulfur dioxide? Sulfur dioxide is SO2. And how do you calculate MR? It's the sum of the AR. So sulfur is 32, oxygen is 16. You have 2 oxygens, times it by 2, add them together gives me 64. D is the correct option. Magnetite is an ore of iron which contains the Fe2 plus ion, the 3 plus ion, and the O2 minus ion only. So it's going to have, whenever you have irons, it's going to have the 2 plus and the 3 plus ions. What is the formula of magnetite? So let's write it down. You have 2 irons, so it must have the 2 plus ion and the 3 plus ion, and you have 1 oxygen, so the charge here is -2. So plus 5 is not balanced by -2, sir. Plus 5 needs a -5 to be balanced. So A cannot be the correct option. If you check B out, you have +2, +3, and oxygens are 3. So you have an overall, you have 3 -2s, right? So here that's -6. So plus 5 does not need a -6 charge. It needs a -5 charge. So B is also wrong, right? And if you check C out, in C you have Fe3O2. Which means you can have a +2, +3, that's for sure. You're going to have a +2 and +3, that's for sure. But the third iron can either be a +2 or it can be a +3. And oxygen is -2 and you have 2 oxygens. So the overall charge that's going to be there is going to be -4. Remember, an ionic compound has no overall charge because the charges balance each other out, right? So the number of positive charges that you have should be equal to the number of negative charges that you have. So here you have 3 + 2 + 5, that's basically 3 + 2 + 2, that's basically 7 plus, and here that's basically +8. None of this is equal to -4, therefore C is wrong. But you check D out, in D you have the same 2 iron, the same 3 irons, but here you have a charge of -8, right? And absolutely for D, this satisfies the option number D, right? So you can have a +2, a +3, and another +3 to satisfy the charge of -8, right? So the charge is, the negative charge must be equal to the positive charge in an ionic compound because ionic compounds have no overall charge. So you must know that, and that's why D is the correct option. And those of you who don't know this, your understanding of ionic bonding is very weak because you guys, why is magnesium chloride MgCl2? It's not MgCl2 because Mg has 2 plus, Cl has 1 minus, cross multiply. The cross multiplication is just a simple technique. The actual concept is that Mg is 2 plus and it needs 2 minuses because chloride is only 1 minus. How many chlorides do we need? We need 2 chlorides, right? So the number of positives that you have must be equal to the number of negative charges that you have. Concentrated aqueous sodium chloride. Aqueous sodium chloride means you're going to have the sodium ion, the chloride ion, the H plus ion, and the OH minus ion because it's aqueous. Sulfuric acid, the H plus ion, the SO4 2 minus ion, and because it's aqueous, it's also going to have the OH minus ion, right? So these are all the ions that are going to be present. Now it says which row identifies the product at the cathode. Cathode is the negative electrode. Panic. Positive is anode, negative is cathode. Now at the cathode, the hydrogen ion will discharge here, and again the hydrogen ion will discharge here. That's why B is the correct option. C and D were automatically wrong because for sodium chloride, obviously the hydrogen. And yes, if it talked about the anode, then at the anode, in this particular case, the chloride ion would discharge because it's concentrated, and here the hydroxide ion would discharge to give you, here it would give you chlorine, and here it would give you oxygen. So chlorine and oxygen, this is what happens at the anode, not at the cathode. Electrolytes can be broken down by electrolysis. Which rows are correct for the electrolyte? Remember, electrolytes are just solutions which can conduct electricity because of the free moving ions, right? And you can break them down by electrolysis because you can pass current through it. Now, he's given me some electrolytes and we have to determine the products. Check this out. Cathodes are my negative electrodes, right? And anodes are my positive electrodes. How in the world can a negative ion be attracted to the negative electrode? Like charges, they repel. Unlike charges, attract. So automatically, right off the bat, I could eliminate 3 out. Now between 1, 2, and 4, let's check this out. Dilute aqueous potassium chloride. Because it's dilute, the chloride ion would not discharge. The hydroxide ion would discharge to give you oxygen. That's what's going to happen at the anode. Beautiful. And between the potassium ion and the hydrogen ion, obviously hydrogen ion is going to win the race and it's going to give you hydrogen gas. So 1 is correct. If we talk about 2, you have concentrated hydrochloric acid. So concentrated hydrochloric acid, you're going to have the H plus ion, the Cl minus ion, and the OH minus ion because it's obviously an acid. So it must be dissolved in water and it has the OH minus ions. Now, because it's concentrated, the hydroxide ion will not win the race, the chloride ion wins, and between the H, you only have the H plus sign, so hydrogen is going to discharge at the cathode to give hydrogen gas, and the chlorine is going to be formed at the anode because the chloride ions win the race. Remember, for the anions, which are the negative ions, the rule is that the hydroxide will always win the race no matter if it's dilute or concentrated, except for when it's concentrated and you have the halide ions. Halide ions are chloride, bromide, iodide. So if you have these ions, only then will the hydroxide ion lose. Other than that, it will always win the race. Like in this case, it won the race between the chloride and the hydroxide won because it was dilute, right? So 1 and 2 are correct, therefore A is my option. If you check 4 out, why is 4 wrong? Because at the cathode, sodium ion doesn't discharge, right? It says concentrated aqueous sodium bromide. So between the sodium ion and the hydrogen ion, it's aqueous. So you obviously have the hydrogen ion and the hydroxide ion, and the bromide is right here. So between sodium ion and hydrogen wins the race, and he's shown the discharging of, or the half equation of sodium ion, which is not correct. So 4 is also wrong. Which statement about hydrogen oxygen fuel cells are correct? Well, hydrogen oxygen are fuel cells. Let's check out the options. Hydrogen in the fuel cell, hydrogen reacts with oxygen to give H2O and to also generate electricity. And it's also very beautiful for mankind because it does not produce any carbon dioxide. It only produces one chemical product, that is H2O, which is environment friendly and does not lead to global warming like our combustion engines where we use petrol, etc., right? So hydrogen is extracted from clean dry air. Are you sure, man? No, it's extracted from reforming. It's extracted from methane, natural gas, and the reaction is called reforming, right? Nobody cares. And it's extracted from maybe like you perform the cracking of hydrocarbons, right? How do you obtain it from dry air? If hydrogen was present in dry air, like use your common sense. If hydrogen was present in dry air, there would be explosions everywhere around you. Why? Because hydrogen is highly flammable. That's why we should be thankful to the Lord for not doing something like that, right? So A is wrong. The only product is carbon dioxide. No, the only product is H2O, not carbon dioxide. Dude, what are you on about? The reaction is endothermic. No, sir, it gives off heat. Then if it were endothermic, how could you use it as fuels, right? The reason it's used as fuels is, remember, whenever we talk about fuels give us energy, right? Fuels give out energy in the form of heat. So it's exothermic, not endothermic. If it were endothermic, then we would provide it energy. Are we dumb balls? How else would you use it as fuels? No toxic gases are produced? Absolutely, because H2 is not a toxic gas. Which statement defines the activation energy for a reaction? Is the minimum energy that reactant particles need or colliding particles need in order to undergo successful collisions and to react. So this is correct. It is the minimum energy that colliding particles must have to undergo successful collisions or to react, right? It is the minimum energy that endothermic requires. That's not the definition, right? We've not studied anything like that. It's the minimum energy that all particles would require, regardless of whether it's an endothermic reaction or exothermic reaction, right? We need that activation energy. It is the maximum energy. No, not maximum, CD wrong. The equation for, if I were you, I would not solve this question until and unless I was done with my entire paper, because this seems to be such a long calculation. So we have to calculate the enthalpy change, right? Let's calculate it. So here you have how do you calculate the enthalpy change? Enthalpy change is the energy taken in during bond breaking minus the energy given out during bond formation. So we are going to calculate the energy taken in during bond breaking of all the reactants, and then we're going to calculate the energy given out for all the products that formed, right? So let's check this out. So how much energy is going to be taken in? This bond is going to break, this bond is going to break, this bond is going to break, and this bond is going to break. So how many CH bonds do you have? You have one CH bond here and one CH bond here. So you have two CH bonds. And how many moles of CH bonds you have? 2, right? So 2 times 2 into CH bonds. And how many C triple bonded to C do you have? You have one C triple bonded to C, so that's going to break. And how many moles of this do you have? You have 2 moles of this, right? Right here, 2 moles. Done. And how many oxygens do you have? You have one O double bonded to O, and you have 5 moles of that. And you have to just plug in the values after this, right? Then if you check out the bonds being formed, you have one C double bonded to O, another C double bonded to O. So 4 times 2 C double bonded to O. You have 2 C O bonds, right? And then you have how many OH bonds? You have one OH bond right here and the other OH bond here. So 2 times 2 multiplied by OH bond. So why are you adding the 2? Well, obviously because you have 2 moles, 4 moles, 5 moles, 2 moles, right? Bond energy is only for 1 mole. So the number of moles that you have, you obviously have to multiply it by that. Plug in the values, everybody. I can say 2 times 2 is 4, right? So 4 times CH bonds. Can I do that? I'm solving it with you guys for the first time as well. So 4 times CH bonds. CH bond is basically what? It is 415. So 4 times 415 plus 2 times C triple bonded to C, that's 837, plus 5 times O double bonded to O, that's basically 498. Done, sir? Can we calculate it? It gives me 5824. Done? And if you calculate this, so 4 times 2 is 8. 8 times C double bonded to O, which will give me like 805. So 8 times 805 plus 2 times 2 is 4. So 4 times OH. OH is how much? It's 464. Done. What do we get? 8 times 805 plus 4 times 464. 8296. So 8296 is the energy given out. So enthalpy change is given by bonds, the energy taken in during bond breaking, which is 5824 minus 8296. How do we calculate it? 5824 minus 8296. That gives me minus 2472. But remember, this is the amount of energy given out for every 2 moles of ethion. This is for every 2 moles of ethion. We've done a lot of questions in theory like this. It's saying calculate it for 1 mole. You know, in theory, this question would be roughly for 4 to 5 marks. That's the beauty. So for 1 mole, you just divide it by 2, right? This is for 2 moles. For 1 mole, you divide by 2, you get minus 1236 kilojoule per mole. B is the correct option. In experiment 1, small lumps of limestone are added. Small lumps mean what? Means increase in surface area, which would result in more particles being exposed, and therefore this would increase the rate of reaction. Why? Because obviously the frequency of collisions increase because there are more particles exposed. And it says it's taking place at 40 degrees Celsius. Great. And now he's saying that he has changed some conditions for experiment 2. And if you check this out, experiment 2 is at a lower rate, right? Being at a lower rate is not defined by, hey, this graph is down below experiment 1, so it means it has a lower rate. No, sir. The reason why it has a lower rate is either you could draw tangents to explain it. This is a steeper tangent compared to this. Or if you're weak in drawing tangents, what you could do is you could check the time it takes for the reaction to be over. So this reaction, let's suppose, took 10 seconds to be over. Experiment 1. Experiment 2 is getting over right here at like maybe 15 seconds because the line is getting flat right here for experiment 1, which means no more carbon dioxide is produced, so the reaction is over. And for experiment 2, the line is even getting flat right here. So it takes more time for experiment 2 to finish than for experiment 1. So we can safely conclude that experiment 2 is slower. And if experiment 2 is slower, that means you would not use powdered limestone. You would either use small lumps of limestone at a lower temperature, or you would use large lump of limestone, right? So small lumps of limestone at a higher temperature? No, sir. If it were at a higher temperature, then the rate would obviously increase. Why would it be a lower rate? So D is wrong. Large lumps means lower surface area or decreased surface area, and decrease in surface area means less particles will now be exposed, and if less particles are exposed, therefore the rate of reaction will decrease because the frequency of collisions decreases. So A is correct. The temperature is remaining constant in this case. In the Haber process, nitrogen and hydrogen are reacted to make ammonia. Oh, great. Okay. The forward reaction is exo. So if the forward is exo, the backward should be endo. It says which conditions will produce maximum yield of ammonia? Well, for maximum yield of ammonia, you need to favor exo. And how do we favor exo? Low temperature favors exothermic. So low temperature favors exothermic. Therefore, A and C are wrong. And between B and D, you also need to look at the pressure. So what will happen to the pressure? On the left hand side, you have 4 gaseous moles. And on the right hand side, you have 2 gaseous moles. So what happens? Increase in pressure favors fewer gaseous moles. So if you increase the pressure, it will favor fewer gaseous moles. The position of the equilibrium will shift to the right hand side, making more ammonia, right? So you need a high pressure, not a low pressure. Done? Okay, perfect. Moving on. The Ostwald process is used to make nitric acid. They're just using jargons at this point. To be very honest, it's just confusing you with these huge words. Ostwald. Don't get confused. Just think about the question. Think about the requirement of the question. It says a catalyst, the conditions are used, a catalyst, a pressure, a temperature. Which of these conditions are used in contact process? We also use a catalyst that contains a transition element in contact process, which is V2O5. The vanadium pentaoxide. In vanadium pentaoxide, the vanadium is the transition element. Right, so he's saying here he's using a catalyst containing a transition element. So yes, in contact process we also use a catalyst that contains a transition element. So one is correct. A pressure of 10 atmospheres, no. In contact we use 2 atmospheres. Pressure temperature of 800, no. In contact we use 450 degrees Celsius. So 2 and 3 are wrong. 1 is the only correct option. Done, done, done. Hydrogen iodide is dissolved in water. Well, obviously, if you dissolve in water, it's no longer going to be called hydrogen iodide. It's going to be called hydroiodic acid. It's going to be an acid. And it says, which row describe the final color scenes when you test it with damp red? Sir, if you test this hydroiodic acid with damp red litmus, what will happen? It'll remain red. It won't turn blue because acid, they turn damp blue litmus red. If it's already red, it'll remain red. So blue, wrong. Now it says what will happen if you test it with potassium manganate. Potassium manganate is the oxidizing agent and iodide ion is the reducing agent. So what's going to happen is they're going to react and the iodide ion is going to, because this is an oxidizing agent, it's going to oxidize the iodide ion to iodine, I2 aqueous, which is going to be brown, right? So C is the correct option. And if you cannot, if you cannot link these in your brain, think about an example that you've studied. When you reacted chlorine with potassium iodide, right? So it's going to give you KCl and it's going to give you I2 aqueous. What's happening? Well, obviously the potassium iodide is a reducing agent. So here you could think that the hydrogen iodide is the reducing agent, right? So the hydrogen iodide, or in this case it's hydroiodic acid, not hydrogen iodide because it's the acid. So what's going to happen? The chlorine was displacing the iodine from its salt solution, right? So once it displaced it, you got I2 aqueous. Similarly here, because this is oxidizing agent, this is reducing agent, they're going to react together. The potassium manganate is going to displace, you could say displace, but the potassium manganate is going to react with this hydroiodic acid and it's going to oxidize the I- into I2 aqueous. So the resulting solution is going to be brown, right? And you guys might think to yourself, hey, potassium manganate is purple, right? So yes, it is purple and it go from purple to colorless. This will go from purple to colorless and this will go from colorless to brown. So if something is colorless and you add a brown color to it, obviously the last final color would be brown. It's like saying there's water and you add a red dye to it. So obviously the color of water is colorless, but if you add a red dye, it'll become red. So obviously potassium manganate will become colorless, but if there's I2 aqueous being formed, it'll also turn brown. I don't think this MCQ should have been tested here. Which statements too much brain to use? Which statements about aqueous ethanoic acid is correct? It can be produced by oxidizing ethanol with potassium iodide. No sir, potassium iodide is a reducing agent. We need an oxidizing agent like acidified aqueous potassium manganate or acidified aqueous potassium dichromate, which is not in your course. It reacts with magnesium to produce hydrogen gas. Yes, any metal reacts with an acid. Any metal, when it reacts with an acid, it displaces the hydrogen to give you salt, and obviously the hydrogen that's displaced gives you the H2 gas. So that is correct. It has an approximate pH value of 3. Yes, it's a weak acid, so absolutely it does. Done. It produces esters called methanoates. Ethanoic acid will give you an ester called ethanoate, not methanoate. Are you dumbo jumbo? He's trying to confuse us, man. It ain't working, dude. Which element forms an acidic oxide? Well, for it to form an acidic oxide, it must be a non-metal oxide, right? And then if there are some exceptions, we can look into that. But calcium oxide is basic, lithium oxide basic, magnesium oxide, sulfur oxide is acidic oxide like SO2 and SO3. It takes you 1 second to do such MCQs. Which statement describes the properties of hydrochloric acid? Carbon dioxide is produced when limestone. Limestone is calcium carbonate. So metal carbonate, when it reacts with an acid, it's obviously going to give you metal chloride. In this case, it's going to give you calcium chloride, which is the salt. It's going to give you H2O and carbon dioxide. So yes, A is the correct option. Check BCD out. Hydrogen is produced when sodium hydroxide reacts with hydrochloric acid. No sir, it's not produced when they react together. H2O is produced. Base and acid, when they react, they produce H2O, not H2. Methyl orange turns yellow. No, it turns red. C is wrong. Red litmus paper turns blue when dipped in. No, red litmus paper remains red, dude. Acid turns a damp blue litmus red. If it's already red, it'll remain red. And see, this MCQ could have helped you solve the previous MCQ. Elements P and Q have the same number of electron shell, which means they are in the same period, right? If they have the same shells, they must be in the same period. An atom of Q has more electrons in its outermost shell than an atom of P, which means they are in different groups. If they have different outermost electrons, that would mean they are in different groups. And because Q has more electrons, this would be more towards the non-metal side, right? And because QP has less electrons, this would be more towards the metal side, because we know metals are group 1s, group 2s, and some of group 3s like aluminum, right? So they have fewer electrons in its outermost shells, right? So it says which statement are correct? P and Q are in the same group? No, they are in the different group. I'm solving this for the first time with you guys, so you guys can check the marking schemes when it's released. I don't think anybody has solved it, and I also don't think anybody has released the marking scheme yet. So I'm solving it with you guys for the first time, but if I'm solving it conceptually, all my answers should be correct if I'm applying the concepts, right? P and Q are in the same period? Absolutely. P has a greater tendency to form positive ions. Yes, because it's more towards the metallic side. The oxide of Q is more basic than the oxide of E. No. It's going to be more towards the non-metal side, and when it's more towards the non-metal side, there are high chances that it's more towards the acidic oxide. So it's going to be not more basic, it's going to be less basic. Probably it might even be an acidic oxide. So 2 and 3 are correct. C is the correct option. And they are moving towards a type of testing which they do in A levels, to be very honest. In A levels, they do testing like this. That's why AS MCQs are considered very, very difficult by students, but it's the easiest if you're able to apply concepts. So learn how to apply your concepts instead of rote learning MCQs. This is going to be fun this year. The MCQ paper, right? Which substance reacts with dilute sulfuric acid to form a salt that can be removed from the resulting mixture? Well, by filtration. So if you want to remove a salt by filtration, obviously the salt must be trapped in the filter paper, and for it to be trapped in the filter paper, it should be insoluble. So essentially saying which substance, when it reacts with sulfuric acid, would give you an insoluble sulfate. Barium chloride, check this out. Barium chloride means you have the barium 2 plus ion, the chloride 1 minus ion, and sulfuric acid is H plus and SO4 2 minus. And when the barium ion comes into contact with the sulfate ion, they're going to make a white solid, a white precipitate is going to form, which can easily be obtained as residue when you perform filtration. So A is correct. Sodium hydroxide is going to give you sodium sulfate aqueous, which is not insoluble, it's soluble, so it will not be trapped in the filter paper. By the filter paper, copper does not react with dilute sulfuric acid. Why? Because it is less reactive. It is below hydrogen in the reactivity series, so cannot displace it. Copper carbonate is going to give you copper sulfate aqueous, which is again soluble, right? You know your solubility rules. All sulfates are soluble except for LMS Castrobar. In your course, you only have lead and Castrobar calcium. Sorry, not calcium, barium. So lead and barium sulfate are insoluble. Other than that, they're all soluble. Astatine is below iodine in reactivity series, not reactivity, in group 7 in the periodic table. Which row describes the properties of astatine? If it's below iodine, it must be a solid, it can't be a gas, because down the group, the state changes from a gaseous state to a solid state. Chlorine and fluorine are gases, bromine is liquid, and then iodine, astatine, and tennessine are solids. So now it says it displaces iodine, but does a reactivity? It displaces iodine. No. So down the group, the reactivity of group 7s decreases, right? So how can it displace iodine? It cannot displace any iodine. It does not displace iodine, chlorine, bromine, because it is less reactive than chlorine, bromine, or iodine. Therefore, it cannot displace it. Which property of copper explains why it's classified as transition element? Copper can be bent into different shapes. This is a good MCQ. Copper can be bent into different shapes, but it does not explain why it's a transition element, because all the other metals are also malleable and ductile, most other metals, right? Copper forms the 2 plus and the 1 plus ion. Yes, they have variable oxidation state. That's only limited to transition metals. So B is correct. Copper is a good conductor of electricity. Dude, metals are all good conductors of electricity because of delocalized electrons. Copper has a low density. Well, if copper has a low density, then sodium and potassium also have low density. They float on water. So D is wrong. So he's trying his best to confuse us, but he can't. Now it says brass is an alloy. Alloys are mixtures of copper and zinc. Which, oh, brass, copper, and zinc are all gonna all conduct electricity. I've been waiting for this question to be tested for so many years now. I teach this every single session, and it has been finally tested, sir. Remember, when mixture forms, they have the same properties as their constituents. Whatever the mixture is made up of, all the properties of each particular element in that mixture, the mixture is going to contain that property. So if brass is a mixture, it's an alloy, it's going to conduct electricity because conduction of electricity depends on delocalized electrons. And copper and zinc properties are going to be possessed by brass, right? So brass is also going to have delocalized electrons effectively, right? So it can also conduct electricity. Maybe not as good as copper and zinc, or maybe better than it, maybe not as good as copper and zinc, but it will still conduct electricity because of the delocalized electrons. So one is correct. Thankfully, it has been tested. Brass is a compound? No, it's a mixture of copper and zinc. There's no chemical change taking place. Brass is harder than zinc? Absolutely, it's harder than zinc. That is the entire concept of alloys. We make alloys to make our metals harder. Why? Because the regular structure is disrupted or distorted because of the different size of atoms, and therefore the layers can no longer slide over each other, right? So 1 and 3 are correct. C is the correct option. And therefore it's no longer malleable and ductile. Okay. 28. The equation for the reaction of metal M with aqueous zinc sulfate is shown. Metal M is a solid and it's reacting with zinc sulfate. Obviously, if it's reacting with zinc sulfate and displacing Z, I can safely say that metal M is more reactive than zinc, right? That's why it can displace it. And I can also deduce one more thing, that the metal sulfate is aqueous, which means this is soluble. I can deduce these two things. Okay, let's explain this MCQ. It says, which statement explains why metal M reacts? Because it's more reactive. Zinc is less reactive than metal M. That's true. Because M is able to accept electrons from zinc ions. Zinc 2+ ions, they already have lost electrons. How can metal M accept electrons from zinc 2+ ions? What is essentially happening is, effectively, if you think about it, this metal ions is giving electrons to the zinc 2+ ions to make it into zinc solid, and itself it becomes a part of this sulfate to give you the metal sulfate. So effectively what's happening is the metal is losing electrons to the zinc 2+ ions to make it zinc, and metal sulfate is the salt that is being formed. That's what's happening, right? So that's not true. A is incorrect. Why? Because M is not accepting electrons from the zinc ions, although the zinc ions are accepting electrons from M to become zinc. Now it says zinc is a more powerful reducing agent than M. Maybe you did not understand that, so let's skip this. Let's look at C and D, and then at the end I'll explain B to you as well. Zinc is more reactive than M. No, sir, zinc is less reactive. That's wrong. Now between B and D, let's check D out. Zinc ions can remove electrons from M. Yes, the zinc 2+ ions are right here. They're going to remove electrons from M. Essentially, they're going to gain the electrons from M, and they're going to become the zinc solid, and this M is again going to make the salt. So D is the correct option. Now, why is B wrong? You might think, why is this B-areno wrong? Well, it says zinc is a more powerful reducing agent than M. If I write this equation, this products that have been formed, zinc plus MsO4 aqueous, will there be any reaction taking place? Yes, no. No reaction. Why? Because this metal is more reactive. So zinc is not a more powerful reducing agent. It is a less powerful reducing agent than M. What do we mean by reducing agent? A substance that oxidizes itself to reduce other. Can zinc reduce this metal? Can zinc give electrons to this M and reduce it to make it into a metal M and become a part of this salt? Absolutely not, right? There is no reaction. Zinc cannot reduce. Zinc cannot give its electrons to M. It cannot do that, right? Because it is not a more powerful reducing agent, it's a less powerful reducing agent. So B is also wrong. I don't think such MCQ should have been tested, to be honest. Using too much brain. In the blast furnace, an impurity silicon oxide is removed, silicon SiO2, and it says which, and it's saying is removed by the formation of slag. Which equation represents the formation of the substance which reacts with it? Well, it's an acidic oxide. So for an acidic oxide, you need what? You need a basic oxide, and this is not a basic, or this is acidic oxide, this is neutral, that's acidic, but that's the basic oxide. Absolutely. Calcium oxide is my basic oxide, sir. So C is the correct option. You know, it reacts with calcium oxide to give you what? Calcium silicate, that's slag. And D is wrong again, that's the acidic oxide. Aluminum is extracted from bauxite using electrolysis. Which statement is correct? Aluminum ions are oxidized? No, sir, they're reduced. The aluminum 3 plus ions gain 3 electrons to become aluminum. Gain of electrons is not oxidation, it's reduction. The cathode has to be replaced? No, sir, the anode has to be replaced, not the cathode, right? At the cathode, aluminum is formed. Why does it have to be replaced? Carbon dioxide is produced at the anode. Yes, because you have the O2 minus, you've molten this aluminum oxide, right? So you have the O2 minus, two O2 minus are going to go together to give you oxygen and lose 4 electrons. And this oxygen, because the electrodes are made up of carbon, or you could say graphite, they react with carbon to give you carbon dioxide, and that's why they get used up. There's a decrease in mass of anodes and they need to be replaced regularly, right? So carbon dioxide is produced at the anode, and that's why the extraction of aluminum results in a lot of carbon dioxide being produced, which is greenhouse gas and can result in global warming. Cryolite is added to remove impurity. Cryolite in itself is an impurity. It's added to either improve the electrical conductivity because it gives more ions, so there are more ions to carry the charge, or you could say they are added to lower the melting point because impurities, they lower the melting points. Done. Iron rusts, but aluminum does not corrode easily. Why? Because it forms a layer of its oxide, right? Which statement explains why aluminum does not corrode easily? It is an alloy. Aluminum is not an alloy, it's a metal, man. What's wrong with you? It is below iron in the reactivity series. Firstly, it's above iron in the reactivity series, but that does not explain anything. It is a transition element. Again, it's not a transition element, and even if it said it's just a simple metal element, it still does not explain why it is not corrode. Its surface is protected by an oxide. What happens is the aluminum comes into contact with oxygen to make a layer of its oxide, which is aluminum oxide, and all the inner aluminum is protected. Which explains which chemicals can be used as fertilizer to provide 3 elements. What are the 3 elements? NPK fertilizers: nitrogen, phosphorus, and potassium, right? So you need nitrogen, phosphorus, and potassium, which are the 3 essential elements. So here you have nitrogen and you have potassium, but you don't have any phosphorus. Again, here you have nitrogen, phosphorus, and potassium. So B is the correct option. And if you check C out, nitrogen and phosphorus is there but no potassium. Nitrogen and potassium is there but no phosphorus. What is the color change when water is added to anhydrous cobalt chloride? Cobalt chloride is right here, which is blue, and when you add water to it, it goes from blue to pinkerino, right? So that's blue. That's anhydrous, which means it has no water molecules. And here that's pink. It's a hydrated salt, water of crystallization. So blue to pink. How do, and again, it's not white, and doesn't go from blue to white, it goes from blue to pink. How do carbon dioxide and methane cause global warming? They emit the thermal energy that have absorbed back to the earth. Yes, that's what they do, right? So they emit that thermal energy that they have trapped, and they basically they have absorbed that thermal energy and they re-emit it back to the earth. So A is the correct option. But if you check B, C, D out, why are they wrong? They absorb the radiation directly from the sun. This is such a huge misconception. No, sir. Basically, I'll upload a video on global warming and how these greenhouse gases work, because I don't think even teachers are properly explaining it to the students. Because what happens is, this is the earth and this is the layer of atmosphere, right? And here you have your gases, which are the greenhouse gases: carbon dioxide, methane, and even water, H2O. Not water, water vapor. They are all greenhouse gases. So when the sun radiates, because the sun is very, very hot, there's a little physics involved. Because the sun is very, very hot, it radiates high energy radiation, which is basically your ultraviolet light and in that particular spectrum, right? So the UV light, the ultraviolet rays, the visible light spectrum, they all have a higher frequency, and higher frequency means shorter wavelength. So because they have a higher frequency, shorter wavelength, they have more energy, the greenhouse gases cannot absorb them, and it penetrates through these gases, and it heats up the earth for you. But when the earth when the earth reflects these these radiation, because the earth is cooler compared to the sun, it reflects the radiation, but it's now not the visible light, it's not in the visible light spectrum, or it's not in the it's mostly in the infrared spectrum, which means it has a longer wavelength. Earth is cooler, so that means it has lesser energy. Lesser energy means lower frequency. Lower frequency means longer wavelength. Longer wavelength means that now they don't possess that energy, and these gases can trap them, and these gases re-emit it. So it does not absorb the radiation directly from the sun. It absorbs the radiation that the earth reflects, and which is absorbed by these greenhouse gases. So this was the entire concept. I gave it in a few minutes, but it's much more detailed. So someday maybe. They increase thermal energy lost to space. No, they decrease it. No, that's the problem. They decrease it. They are being these radiations, they want to escape and they want to be lost to space, but these gases are absorbing it. They are trapping it. They reduce reflection of thermal. No, reflection is, they're not related to any reflection. What's not? They just trap the radiation, or trap the energy that has been already reflected by the earth. So that the reflection does not depend on these things. 4 statements about photosynthesis are listed. Number 1, chlorophyll is required for photosynthesis. Absolutely. The equation is, no, that's not the equation, man. That's the equation for respiration. Are you dumb? That's respiration, not photosynthesis. Photosynthesis required energy from light. Absolutely it does. You reverse this equation, that's the equation for photosynthesis. Photosynthesis releases carbon dioxide. No, it absorbs carbon dioxide. Carbon dioxide reacts with H2O in the presence of sunlight and chlorophyll to give you glucose and oxygen. So 1 and 3 are correct. Some absurd statements. Which molecules are structural isomers? Sir, structural isomers, for them to be isomers, they must have the same molecular formula but different structural formula. Let's check out the molecular formula. Meth, eth, pro, bute, pent. This is pentane, so it should have the formula C5H12, right? This is what? It's meth, eth, pro, bute, pent. This is pentene, so it should have the formula C5H10. Done. This is meth, eth, pro, bute, pent, hex. This is hexene because of the double bond, so it should have the formula C6H12. This is meth, eth, pro, bute, pent. They're all carbon-carbon single bonds, so that's pentane, C5H12. We don't need to name it. 1 and 3 are isomers. 2 and 4, they don't even have the same molecular formulas, right? So between all of these, which two have the same molecular formula? 1 and 3, so they must be isomers. They must have, and their structures are different. We don't need to name the structures. Which statements about the reaction of ethene with steam are correct? So ethene is an alkene. It's C2H4, reacts with H2O gas to give you what? To give you C2H5OH, which is ethanol. Ethene gives you ethanol. Great. That says the product has a higher molecular mass than ethane. Ethane is C2H6, which is what? C2H6, 2 times 12, that's 24. 24 plus 6, that's 30. Done. And C2H5OH, so that's 24. 24 plus 6, 30. 30 plus 16, that's 46. So yes, the product does have a higher molecular mass than ethane. Done? The product reacts with bromine aqueous. No, it doesn't, because they are all carbon-carbon single bonds. There are no double bonds, so it will not react. The number of electrons shared between carbon atoms increases. That's a good thing, right? That's a good question. Let's check this out. Initially, when you had ethene, it had 4 electrons being shared between the carbon atoms. Now you have ethanol, so all the carbons are carbon-carbon single bonds, right? So carbon-carbon single bonds are only sharing 2 electrons, not 4. So the number of electrons decreases? Absolutely they do. Shared between the carbon atoms. Remember, shared between the carbon atoms do decrease. You went from 4 to 2. The reaction produces alcohol and hydrogen. No, sir, no hydrogen is being produced, or else why would it be called an addition reaction? Addition reactions are those reactions in which only one product is formed. So 1 and 3 are correct. B is the correct option. Methane and chlorine react. Well, obviously there's this substitution reaction taking place, and you need UV light. So UV light is needed. Nickel catalyst is needed for the addition reaction of hydrogen to an alkene. And this is not an addition reaction. That's the substitution reaction. Parts of a structure are shown. If you put a cut at the linkage, that's the amide linkage. That's the amide linkage. Put a cut at the amide linkage. Boom, 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 to go into the monomers. Boom, boom, boom. I've not even read the question, but that's my dicarboxylic acid. Between the 2 cuts, you have your monomers. That's my diamine. And this gives me what? Nylon. That's nylon, right? Dicarboxylic acid and diamine. And here you have a carboxylic, this is the carbonyl carbon, but when you go into the monomer, that was the acid and this came from the amine, right? So carboxylic acid and the amine or the amine, it's not amine, it's amine, right? So carboxylic acid and amine, so it's this came from the acid and this came from the amine or amine, so amino acid, so that's basically protein. Amino acid, amino, oh yeah, it's amino acid, so it's amine, not amine. Who cares, man? Okay, monomers X and Y are different, absolutely. That's a dicarboxylic acid and a diamine, and that's amino acid. So they're different, they're not the same. And the linkages of X and Y are different. No, they're the same. They're both the amide linkages. Amide. That's why they're both polyamides, but nylon is a synthetic polyamide and protein is a natural polyamide. So they have the same linkages. Substance Q is tested using a paper chromatography. The resulting chromatogram is shown. Okay, great. It has 2 spots. So obviously it's not a pure substance, or else it would just give you 1 spot. So Q is a pure substance? No. For pure substance, only 1 spot would have been there then. RF value of the lower spot is 0.25. Now I can't use my ruler and I don't have a ruler to measure the distance from the baseline to this spot right here and then to measure the distance of the solvent front, but I could safely assume 0.25 mean 25%. Check this distance out. You take the distance from the middle of the spot. Is this spot at 25% of this entire? No, it's like at 75%. So the RF value is probably like 0.75. For it to be 0.25, it should have been like right about here, right? So that's through common sense and knowledge. So B is wrong. But even if you wouldn't eliminate B, check out C and D. Q is a compound of 2 elements. Q is a compound of 2 elements. So check this out. Q is a compound of 2 elements. Yes, that might be true because why did I make such a huge difference out of it? Such a huge, why did I make such a huge issue out of it? It can be, it may be, but remember, it's not necessary. Are you basically implying, look at this. In this particular MCQ, the dude is trying to imply that this compound has 2 elements because there are 2 spots. Are you stupid, man? Are you stupid? No, 2 spots does not mean that it has 2 elements because chromatography is just a separating technique. Compounds cannot be converted back into its elements by physical means, right? So him saying that it's a compound of 2 elements is absurd because that's not true. That's not possible. That's not, that's not logical if you are implying that these 2 spots are there, so it means 2 elements. No, sir. So it's not, it may be, but it's not. Q is a mixture of at least 2 different substances. Absolutely. It can have at least 2 different substances because some of the substances might not be visible. For that, you might need a locating agent like the amino acids. For amino acids, what do we need? We need like a locating agent, which is ninhydrin. So C must be the correct option. D doesn't make sense. If the marking scheme is released and they say D is the correct option, then they're stupid, to be very honest. D is not a sure short answer, right? So yeah, C is the correct option. D doesn't make sense because Q is a compound of 2 elements according to my professional judgment. No, sir, because you are basically implying that these 2 spots mean 2 elements, and that's not the case. Done? So that was the entire paper. I hope you all enjoyed. All the MCQs are correct, obviously. After this, if some student, types in the comment box, sir, the official marking scheme says E or B or U, then we'll correct it, we'll rectify it. But yeah, that's that, guys. See you guys in the next bit. Hope you enjoyed. Do this paper and enjoy. Bye-bye. Ciao. Ciao. Bye.